Hey students, we're finishing up Unit 2 on linear equations and graphing today. And you should have in your notes on page 21, not the same thing you're seeing on my screen, but a place that talks about parallel and perpendicular. But before we look at that, let's just look at what does that even mean, right? What do those words mean? So if you look at the diagram here, minus my extra line, when we name these lines, we're naming them here with 2 points. So when I see line KN, what I'm talking about is this line that goes through these 2 points. Notice it does have arrows on the end because it goes on and on forever. And then TZ is this one that looks slanted on our page. And if we would carry it on out, and since they both have arrows on the ends, those two would cross. So for this page that I'm looking at, notice at the top it says parallel, perpendicular, or intersecting. Sometimes the ones that are just intersecting may just be referred to as neither, that they're neither parallel or nor perpendicular. So parallel, these two are just going to be intersecting. They may not be interesting, but they're intersecting. So parallel lines, an example here that are parallel would be our MH and WB. So MH and WB are parallel. So since I've told you those are parallel, you may have a little better idea about what parallel means because now you have an example of something that is parallel. So parallel lines run, they have the same slope. They are always equidistant apart. So for instance, here in Anderson, Indiana, an example of parallel lines, if I were thinking about streets, right? If I were thinking about streets, Main and Meridian would be parallel, right? They kind of run side by side. They would never cross, and they're always just a block apart. So an example of perpendicular on this drawing would be WB and UE. So WB and UE are perpendicular. So here's UE, here's WB, and notice they intersect, they cross, but they cross in a nice special way. They make this nice perfect corner. So parallel lines have the same slopes. Perpendicular lines, their slopes are opposite reciprocals. And we'll look at that a little more later. And in this case, these two are, one's horizontal and one's vertical, so they're perpendicular. So thinking of our street examples again, if you chose Main Street and 8th Street, those would be perpendicular. They meet at a nice right angle. Makes a nice 4 corners there, right? 4 90-degree angles. Oftentimes streets that are avenues, for instance, Nickel Avenue, it's kind of at a slant, right? If you're downtown, when Nickel first starts, it's like 11th Street, but by the time you're over to Rabel, 11th Street's like 5 blocks north. And so that street kind of slants. Or Martin Luther King. That's not going to make nice, perfect right angles with any of the other streets. It's just going to intersect. It's not parallel to another street. It's not perpendicular. It's going to be intersecting. Now please notice that parallel, perpendicular, and intersecting, they're all relationships. So if I just said, is RS parallel? You would have to say parallel to what, right? Okay, it can't be parallel by itself. It has to be parallel to something else. And so that gives you a little bit of background about what parallel and perpendicular could look like. And they can be slanted too. Parallel doesn't have to mean that they're both horizontal or both vertical. So if I were graphing and I have two things that are both have a slope of 3, they're going to be parallel. And we'll go over and look at some examples of that. So while I was paused, I have gone over to IXL, and this isn't a lesson that you're going to do today, but because this is an easy place for me to make some graphs to demonstrate. So these two equations both say y equals negative 3x, and then we have plus 7 and negative 3x plus 6. So to graph the first one, we know we would start at 7 and go down 3 and over to the right 1. And then the other equation, I just got a different color line. If I go from 6 down 3 and over to the right 1. And what you see happens is those two lines run side by side and they would never cross. They're parallel. So that's an example of parallel lines. Those are parallel. They never cross. So when we get into looking at systems of equations, there would be no solution. Because since they're parallel, they never cross. They don't have any common points. Looks like I have to tell it something else here. It's not gonna. They don't have any common points. They would be inconsistent. So here, negative 6 up 2 over 1, negative 10 up 2 over 1. Again, they're parallel. So what we see is the same about these parallel lines is when they're parallel, they have the same slope. So same slope, exactly the same. They are parallel. So let's look, I'm going to change one of these lines. What if this second line, instead of saying y equals 2x plus 10, what if instead I wanted to graph y is equal to negative 1/2 x plus 10? So to do that, then I would be going to 10, and then down 1 over 2, down 1 over 2, down 1 over 2, and I would end up hitting this line. And notice it doesn't cross, like things could cross in lots of ways, right? They could cross like this and make different size angles. When it's perpendicular, the 4 angles that are created, here, 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 and here, when it's perpendicular, those 4 angles are all the same. So notice what I did with the slope. It's the opposite sign. So it was positive 2, the other one's positive 2. This one is negative, and it's the reciprocal. That means it's opposite and it's flipped. So a whole number as a fraction is over 1, so when I flip it, the 1 becomes on top. So something like y is equal to, let's just say if I did 1/2 x minus 5. There's minus 5, up 1 over 2. It would still cross. Not a very great line there, but it would still cross, but it doesn't make 4 equal angles. That's not perpendicular. It's just intersecting. So if we would make the graph and it makes 4 equal angles, 4 90-degree angles, then it's perpendicular. If I get up with 2 big angles and 2 small angles, it's just intersecting. The ones that don't cross at all, they would be parallel. So what you are going to do in IXL about this is in your notes, by the way, in your notes, if I can get to that page. This page needs to come over here, sorry. Notice there's a reminder about our horizontal and vertical lines, and then parallel lines tells you that the slopes are the same, and perpendicular that the slopes are opposite reciprocal. So if I'm given that this line is 3x plus 5, and they ask me for the slope of a perpendicular line. By the way, this little symbol means perpendicular. These 2 L's next to each other mean parallel. So the slope of a perpendicular line, I take this 3, make it the opposite sign, and flip it. And then we can find equations for lines also. But the first thing we're going to do is just identify whether things are parallel, perpendicular, or neither in an IXL lesson. So in S25, that is one that you are assigned today, S25. So let's go to S25. S25 doesn't have a place for me to show you that graph, so. Yes, show us. There we go. So it says R is 4/3, and it's perpendicular, or R is 4/3, and S is perpendicular. So we're starting out at 4/3. If it says parallel, you're going to type in the exact same thing. If it's perpendicular, I need to change the sign and flip it over. So I'm just going to type -3/4. So here, are they parallel? That would mean they have to be exactly the same. Nope. Are they perpendicular? Are they opposite signs and flipped? Yes, they are. Now, if they were different, but not opposite and flipped, we would say neither. And neither is the same as saying they are just intersecting. So if it says parallel, we're just going to type in the exact same number as we just had. So parallel to negative, and that slope is negative 4/7. This one says me too. So negative 4/7. Perpendicular, opposite sign. So if it was negative, now it's going to be positive, and then 7/5. So it still flips. So if they give you the slope, pretty straightforward. Now they give us an entire line, and we have to remember which of those two numbers represent the slope. So the slope, remember, y equals mx plus b. So the slope is going to be the number in front of the x. So the 6/7 is the slope, and then perpendicular, so I'm going to flip it over to get negative 7/6. So I have to find the slope in the equation now, and then if it says parallel, keep it the same. If it says perpendicular, opposite and flipped. Be sure you're using that number in front of the x. So this one says parallel, and again my slope is that coefficient of x. So 2/7. Parallel, we use the same slope. Now they give me two equations. I'm going to compare their slopes. I have absolutely no concern with what the b is. I only care about the slope. Negative 2/5, negative 2/5. They are parallel. So here I have an equation, and it tells me this other line is perpendicular. So I need to take that slope, the 2/5, change the sign, and flip it over. This one says parallel, so I'm just going to keep the same slope. Remember, slope appears before the x. Now, when we get here, things get a little tougher, right? So if this line goes through these 2 points, then I have to find the slope. So we have to find m. So we're going to use our y2 minus y1 over x2 minus x1. So if I do 1 minus 9 over 1 minus 10, or I could go in the other order as long as I'm consistent, and 2 negatives make that positive. The x's do need to get subtracted on the bottom. So that slope is 8/9, but then this says perpendicular, so I'm going to flip it and change the sign. So it was positive, now it becomes negative. So then negative 9/8. So this time, same process, but it says parallel. So 9 minus 2 over 4 minus 1, so 7/3, and parallel means we're going to keep it the same. So 7/3, 7/3. 7/3. Well, gotta get my cursor there. So once you get to 75, you're going to find the slope twice and then compare the slopes. So try that. Find the slope of each and then compare them. All right, so 10 minus 1, remember we've got, this is x1, y, the first x and y, second x and y. So I did 10 minus 1 on top, 10 minus 2 on the bottom, gave me 9 over 8. And then in the second one, I did 2 minus 10 on top and 10 minus 1 on the denominator, and I got negative 8 over 9. So now when I compare those two slopes, they're obviously not the same, so it can't be parallel. And then I need to decide, are they opposite reciprocals? Opposite sign and flipped over? Yes, they are. So we are going to choose perpendicular. And then here I get off a little bit easier. I only have to do one problem instead of two slope problems. So remember that those y's get subtracted on the top, x's get subtracted on the bottom. So I've got negative 4/9. And it says the other line is perpendicular. So flip it, and it was negative, so we're going to make it positive. So my perpendicular slope would be 9 over 4. Go away, little message. 9 over 4. All right, so the other part of your IXL for today is writing an equation for a parallel or perpendicular line. And this is very much like the writing equations we did last time. It's like the ones when we know the slope and we know a point. And remember, then we find B and then we write the equation. So those are kind of what we're going to do. So this says it's parallel to this. So that's just another way of telling me that the slope is the same as that slope. So I know my slope is 1/8, and our point here is -2, -1. Ugh, this looks like this is going to be quite messy. I had hoped it would not start out so messy. So, y equals mx plus b. And the y here is -1. The m is 1/8. The x is -2. And then plus b. So -1 is equal to, these are being multiplied, so this would be -1/4 plus b. So what would I have to add? Or I'd have to get b by itself, so I'm going to add 1/4. 1/4, not 4 over 1. So that would be -3/4 is equal to b. So this equation would be y is equal to 1/8 x minus 3/4. We'll try one more of these, but it is not my intention for it to be nearly that cumbersome with the fractions for b. Alright, y is equal to 1/8 x minus 3 over 4. Alright, well, when we do the review, I'll show you a few more examples of these, but it was not my intention that they would be nearly this messy, so I will probably not assign S26. So, but I do want you to know you will have something similar to this on the quiz. This one's not going to be quite as bad because this is perpendicular, and so the slope for the perpendicular to this would be 2/7 For some of you, you're saying it's still bad because it's still a fraction. But negative 7 over 2, change the sign, flip it over, so 2/7. And then this is my x, this is my y. So 1 is equal to 2/7 times negative 7, because I'm putting them in the y equals mx plus b. Shouldn't have said x and tried to write something else. So then the 2/7 times negative 7 gives us a nice negative 2, because the 7s would cancel, make that a negative 1. And then we would add 2 to both sides, and b would be 3. So that one is not as messy as the last one. So this would be y is equal to, and we use this new slope. So if it's perpendicular and you find a new slope, you're going to use that new slope to find your b, and use that new slope when you write your equation. So y is equal to 2/7 x plus 3. They don't always have to have fractions. They're just being... So I won't assign S26. All right, so not starring that one. I'll take that off our list so that you'll have more time to work on the review. And I'll give you a few more examples on the review of finding these. All right, because it's very much like what we did before. They're just choosing some particularly messy problems to show us. All right, thanks. Hope it's a great week for you.